Assalamualaikum warahmatullahi wabarakatuh. Today our group we gonna to talk about LajakKuruih-N. Next. This is our group member. Next. Okay. Introduction. LajakKuruih tablet is health supplement diet tablets manufactured by LajakLaku company. LajakLaku produce 15 different types of LajakKuruih tablets. We analyze about pill LajakKuruih-N. There are 200 sample data in December 2020, randomly from 3 production shifts, which is morning, evening, and night. For part A, there is a summarization, which is in 3 forms: numerical form, tabular form, and graphical form. This is data in a numerical form. This is data in tabular form in a frequency table, which is frequency of wake. This for tabular form for relative density, the frequency, and the count of relative density. Then this is frequency of tensile strength and also count of tensile strength. And the third form is a graphical form. We do a 3 graphical form, which is for the relative density, wake, and also tensile strength based on frequency.
So for part B, the type of test done is goodness of fit test, and the given information is the data follows normal distribution with mean of 350 milligram and standard deviation of 14 milligram. So we assume that degree of significance is 0.05. So first we do a hypothesis statement. So H naught is the weight of standard tablets produced by manufacturers does follow normal distribution, while H1 is the weight of standard tablets produced by manufacturers does not follow normal distribution. So this is the statistic test. So this table consists of the range of weights, the observed data, which is OI, the probability of H naught to be true, the expected value, which is EI, and the chi-square test value, which is the right column. So after we because there are two datas which are less than 5, so we merge these datas with the data above or below them. So the blue box is the data after merge. So after merging, we can calculate the total of chi-square test, which is 8.88. So this is the rejection rule. So as we know, the rejection rule formula for chi-square test is chi-square alpha k minus p minus 1. So we know that alpha is 0.05. K is the total amount of data that we have, which is 6 after merging, and P, which is the amount of unknown parameters that we have to estimate, which is 0. So we can get chi-square for 0.05 5, which is 11.0705. So this is the border for reject H naught. So as a conclusion, chi-square test, which is 8.88, is less than chi-square from rejection rule, which is 11.0705. The location of chi-square test in the rejection rule graph is in the boundary of accept H naught. Therefore, we will accept H naught. Then the weight of standard tablets produced by manufacturers follow normal distribution with mean of 350 milligram and standard deviation of 14 milligram.
I will explain about part C in our case study. So in part C, we are required to comment on the production of pill, whether it have any significant difference between table weight and the different shift. In order to do this, we need to use one-way ANOVA test. Why we do a one-way ANOVA test is because we are required to compare more than 2 samples of population. So what we need to do is first we need to set up our hypothesis statement where hash note is there is no significant difference between tablet and weight from different shift, while H1 is there is significant difference between tablets and weight from different shift. And the value of alpha, which is the level of significance, we can assume it to be 0.05. So what we need to do next is we need to work on our raw data based on the production of the tablet. In order to do this, we can use Microsoft Excel to help us analyze the data. But we need to arrange our data first based on the three shift, which is arranged in three columns based on morning, evening, and night shift. After that, we can use ANOVA single factor function in Excel to find the p-value. After we have keyed in all the data and so on, we can see what it looks like, just like in this slide. And also from the slide, we can see that our p-value is 0.2897. Then the value of p is compared to our chosen level of significance, which is alpha 0.05. If the value of p-value is bigger than alpha, then the hash note cannot be rejected. But if the value of p-value is less than alpha, then the value of hash note can be rejected. So from the ANOVA table, we can see that we have the p-value is equal to 0.2897, which is larger than our value of alpha, which is 0.05. So we fail to reject hash note. Therefore, there is no significant difference between tablet and weight from different shift at 0.05 level of significance. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir from DAUD. So for my part, I'm going to explain the question B. So for part B, we need to predict the tensile strength of tablets, and given that the percentage of the relative density of the tablet 68%, 74.3%, and 80.1%. So before we predict, we need to determine whether there's any strong evidence on the existence of the linearity between the tensile strength and the relative density of the tablet for LajakKuruih tablet. So in order to do that, we will be using regression and correlation analysis by using Excel. So from Excel, we obtain the regression statistic table, which stated here the multiple R is equal to 0.88, and the multiple R value is actually the correlation coefficient R, and its value is close to unity. And this means that the equation of the linearity is a strong positive linear relationship. So we proceed with the regression test by using ANOVA. And the table obtained from the Excel is this type of table. And from here, we can see that significant F is equal to 1.30189 exponent to the power of negative 67. And since the significant F is less than 0.05, which is significant level alpha, we reject H0. Therefore, there is strong evidence on the existence of linearity in the regression model. So from here, we have successfully proved that the tensile strength and the relative density is linearity. There's a linearity relationship between them, and thus we can predict the tensile strength of tablets by using simple linear regression equation.
For the part D is the asset analysis model to estimate linear equation coefficient. So this is the data. So linear regression equation obtained is this. Y is the tensile stress and X is the relative density. So this is the chart comparison. As you see, the blue dot is the tensile strength and the white dot is the predicted tensile strength. So how to predict the tensile strength data from linear regression equation? So method of calculation using relative density of 868 as an example, we get the tensile strength is this. So using the same method of calculation with different relative density of 74.3 and 80.1,
So we get the predicted tensile strength as below. So this is the predicted tensile strength range with 95 confidence. And to conclude, the linear regression model is a valid model to predict the result of tensile strength of the pill based on its relative density with accuracy of 95%. So thank you.